The broadcast is now starting. All attendees are in listen-only mode.
And welcome to this month's edition of We Speak Linux. A little bit about ourselves. We are set up to teach Windows admins and developers Linux through presentations such as this webinar, blog posts, and peer support such as our Slack channel, and to grow a community of Windows and developers ready to learn Linux. So we have a newsletter that you can subscribe to on our homepage at wespeaklinux.com. We also have a Slack channel which you can join on the /join Slack there. We're on Twitter, and we post all our videos to YouTube as well. Just a little note about some of our upcoming webinars. We have them on the first Thursday of each month. Next month we have Alex Long talking about securing Linux, and that's on October 4th. And then followed by that we have Max Trinidad talking PowerShell on Linux on November 1st. We also have our live chat in our Slack channel. If you join the Slack channel, there's a webinar chat there where you can ask questions, but you can also ask questions today in the panel there on the webinar itself. So today we have Bob Ward presenting SQL Server on Linux and Docker containers. Bob is a principal architect for Microsoft Database Systems Group, which owns the development for all SQL Server versions. Bob has worked for Microsoft for 25 years and has worked in customer support as a principal escalation engineer and chief technology officer, interacting with some of the largest SQL Server deployments in the world. Bob is a well-known speaker on SQL Server, often presenting talks on new releases, internals, and performance at events such as SQL Pass Summit, SQL Bits, SQL Intersection, and Microsoft Ignite. You can find him on Twitter at BobWardMS, or read his blog at blogs.msdn.microsoft.com/BobSQL. So, without any further ado, I am going to hand you over to Bob.
Yeah, thanks, Andrew. I really appreciate it. Let me go ahead and show my screen here and get ready for that. Yeah, let me know, Andrew, if you can see that okay.
Yes, we can see your screen, Bob.
Perfect. Hey, thanks, Andrew. Special shout out to Tracy. Thank you for setting this up and inviting me. I'm honored to be here for you guys today. Kind of fun when I heard about this We Speak Linux. I hadn't heard of this group before, so it's kind of interesting. And it's interesting as well, as you introduced me. This is my 25th year at Microsoft, and I never thought I would see the day that I would actually be in different events and with customers talking about SQL Server on Linux. The irony about my background is before this 25 years at Microsoft, I was actually a Unix programmer. There was no such thing as Linux back then. I was a Unix developer with C++ using Oracle, and so it's pretty ironic to come back here this long into a career with SQL Server on Windows to start talking about things like Linux. So it's been kind of a fun journey for me to get back and learn the Linux operating system, shell, and so forth. So what I'd like to do today is give you both an overview and in some cases kind of a deeper dive and then some demos about SQL Server on Linux containers. Also a little background about why did we do this? You know, why did Microsoft make this choice to go down the path for Linux? I'm a big believer in people having access to anything I talk about publicly. So if you look here on this PowerPoint slide, you'll see this URL, aka.ms bobwardms. This deck that I'm doing for you right now is available on that site. If you go into there, you'll see a lot of different folders for different presentations I've done over the last few years. There's one called SQL Linux, and in there is this actual deck specifically geared towards this presentation today for this group. And I've kind of pulled together different slides I've done on this topic before from other events to make this presentation today. And also I want to make sure you're aware of that anything I'm demoing today is available to you yourself to try in a new set of self-paced free labs that we've built for SQL on Linux and Docker containers on GitHub. So if you just do in your favorite search engine, GitHub self-paced SQL labs or SQL Linux labs, you'll find this GitHub site. And you can go through and see all the instructions we've done to pull down and do demos yourself and labs for SQL Server on Linux and Docker containers. So with that said, let me jump into this. And let me start with a little bit of history because people have asked me many different times as I've been talking about this. I've been talking on SQL on Linux and containers since last year, since we announced it publicly with our release of SQL Server 2017. And you know, one of the first questions I get is like, why did you guys do this? Are you abandoning Windows? And the answer is no. And if you think about several years back, 2014, 15 timeframe, you know, things were ripe around that time for Microsoft to take a hard look at Linux. Businesses wanting choice now, different data types, different languages, different environments they're having to support in their infrastructure. whether it's on the cloud or in their environment. And then customers just wanting choice. I mean, scenarios where customers like, look, I've invested in Linux and in my environment, and I think Microsoft's got some pretty cool products, but they don't run a lot on Linux. Huge, major starting uptake and adoption for Linux in Azure virtual machines. So Microsoft took a look at this landscape. Enterprises wanting to run on Linux, Docker containers starting to kind of hit the marketplace. I remember attending events back in 2014-15, seeing Mark Ruzinovich talk about Docker with Microsoft in mind for the first time ever. I was like, Docker, that's something I haven't seen before, right? So all of these played in the mind of our company and our SQL engineering organization in that time frame, and we made a pretty conscious decision that we have customers out there that would love to run SQL Server in a Linux environment, so why don't we make this investment to go down that path? And again, not because we wanted to give up on Windows, but because we wanted to expand ourselves into new opportunities and new areas. And what I'm going to talk about today, one really deep part of the talk will be about the architecture and how we've pulled this off in such a short time frame to run SQL Server on Linux and SQL Server on Windows, kind of in this same type release. I also wanted you to know another question I get kind of at a higher level from people is anybody using this? Is this just like a toy for you guys? Is it just a testing thing and people just playing with it? And the answer couldn't be far from the truth. We have several customer published case studies out there. DB01 is one of them. A customer that was a Postgres customer, loved Linux. That's the environment. That's what their developers are used to. But it quite frankly couldn't give them the performance they needed. That's from them, not from us. And so they were looking for alternatives, and they had heard about SQL Server, and they started experimenting with SQL on Windows, but they really wanted to use Linux in production. And once we announced that we're doing SQL on Linux, they became an early adopter for us and really helped us do a lot of proof points for performance to ensure that SQL Server on Linux was a very performant. So you can read about that if you'd like online. And we have other customer case studies as well for customers that are in production on SQL on Linux today. I can tell you for myself, and one of the biggest things I do at Microsoft with the SQL engineering team is work directly with a lot of customers thinking about adopting our products and releases. And since the late last year, all the way now through the summer, I have met with, I can't stop counting, at least 50 plus more customers directly, either in person or over like a conference call, in where they've expressed this interest to move to SQL Server on Linux. And this ranges from customers that have been on Windows that are looking to kind of use a mixed environment now. They'd like to make a shift where some of their servers may run with Linux. Maybe they're using containers, or customers that are just new customers running on Linux that are using Postgres, using Oracle, using MySQL, or looking for a new database platform and heard about SQL Server and wants to know more about it. So interest has been huge, and we have certainly many proof points of customers already out there doing large-scale SQL Server deployments with SQL on Linux. And if you think about SQL Server 2017, which we launched last year at Ignite in October, this is kind of the story of that release based on the great work we did in SQL 16, SQL 17, and the biggest thing we did is announce this platform of choice and language, whether it's on Linux, Windows, or Docker containers. And the bread and butter of any database platform is performance and security, and we think we've got the best industry-leading type numbers to prove it. And this is the stuff we made up. This is actually standard TPC benchmarks, which we'll talk about in a bit. We've demonstrated perform very well on Linux with our TPC benchmarks. Again, remember, our partners are the ones that actually produce those benchmarks, not us. Folks like HPE, Lenovo, and so forth, those are the guys that produce the actual benchmarks through a standard through the council. And then the security chart you see right here, it comes from the NIST organization. This wasn't us. This is showing the vulnerabilities that have been published for products and database products, and we show very well compared to the industry out there on how well. We've got great security features, which we'll talk about as well. The new area for us to take a look at in the database world is new technologies, which is why I sometimes call SQL Server no longer a database engine, but we're a data platform. Things like being able to do machine learning in database with things like R and Python and native scoring are new technologies that we've embraced for SQL Server. And you kind of look at the bottom here, we're a big believer in taking advantage of the memory that you have in your environments. So things like column store indexes, in-memory OLTP, all that functionality works within SQL Server, and we take advantage of that. And then consistency being the case that your tools, your T-SQL language, your applications run really well with SQL Server, whether it's being in your private cloud or whether it's in our public cloud. The announcement of our new managed instance feature, for example, with Azure is a much more compatible version of Azure Database now that supports your applications, both whether it be in public or private clouds. And of course, we support Azure Virtual Machine, SQL Server running in that environment. Let's talk a little bit about this platform of choice, though, decision. Again, it wasn't that we're abandoning Windows. We just wanted to be able to open up our database product to different markets. And the Windows team, quite frankly, wasn't totally against this. They were like, hey, as long as you still think that SQL Server is a great platform for Windows Server, which we do, we understand what you guys are trying to do, because there are customers out there that would prefer to have Linux as their environment. And out of the gate with SQL 17, we support Windows Server. We support officially Red Hat, SUSE, and Ubuntu. I've seen customers run SQL Server on Linux with CentOS or other types of Linux distributions, but officially, those are the three out of the gate we support. And of course, we do support Docker containers, and I've got more discussion about containers towards the end of this presentation. And since this is the team that speaks Linux, we need to speak Linux as well. So we didn't invent new stuff, we just embraced the current ecosystem. So for installation, we support package-based installations native to these environments, whether it be Yum, apt-get, or Zypper. Fun story is I was in May at the Red Hat Summit, which was weird for me to be at the Red Hat Summit, and I'm at the Microsoft booth showing SQL Server on Linux, and I just had a series of Linux admins and developers come by the booth going, tell me more about the SQL thing, I don't get you guys, do you really get Linux? And these guys are very, very deep Linux experts. And so I popped up my secure shell and just did a Yum install for SQL Server, and almost everybody said, okay, I'm good, you're good. You guys kind of understand the fact that you didn't try to build something brand new because you're Microsoft. You actually embraced what is normal in these environments. So again, we do embrace those things, and we embrace all sorts of the things that are native to the Linux ecosystem. Now, the one point on this slide I think you should know that's important. Yes, it's a platform of choice. Yes, SQL Server now runs on all these environments, but it's also about database compatibility on these platforms. You're going to see when I'm going to talk here shortly about our architecture that we believe that you need to have an application that is compatible and your T-SQL skills compatible on SQL Server on any of these platforms. And the cool story is that you can take a database backup and restore it. You can take a database backup on any of these platforms and restore it to any of these platforms without any changes. That is really kind of the nice story. So I call it certainly a choice, but choice with compatibility. So we try to dispel that myth from a lot of people that have seen what we've done to say, oh, well, it must not be compatible between the two Windows, SQL on Linux, and SQL on Windows, and the answer is actually not true. Now, having said that, out of the gate when we shipped SQL 17 on Linux, there were some features of what's known as the SQL Server product overall, outside the engine typically, that we could not get into the product for SQL on Linux. And you see this list right here is what that looks like. So if you see kind of these bullet points right here, I've kind of listed out in the major categories of what SQL Server is all about, what's the same between SQL and Windows and Linux and what's different. And I thought I'd first call out to you on the slide right here, the word planned. So if you looked at this slide maybe 2-3 months ago when I presented at a conference, you would just see a blank for replication or Polybase or DTC or machine learning services. Now it says plan because we are actively working on the next release of SQL Server, and we absolutely have plans to make sure that when we release that, and we'll talk a little bit at the end of this session about our plans going forward, but when we release that, these will all just be, all these bullets will all be folded in, and so it's exactly the same. And there's even some discussions about should we, once we do that, consider porting back any of these changes back to SQL 17. That still hasn't been decided, but the point is that we want to make sure that if there's any reason why you're using SQL Server today, let's say with replication, and you can't go to Linux, we want to make sure we unblock those stories. I do want to point out, though, the blank at the top where it says analysis services, reporting services, MDS, and DQS, because I do get that question. The SQL Server engineering team, we don't own those resources. It is another team at Microsoft. We work closely with them because they're part of the SQL Server brand and product. Those teams have not made decisions yet on whether they would actually allow their services to run natively in a Linux environment or within the architecture, which I'm going to show you. You certainly can take those services on Windows and point them to a SQL on Linux because, again, it's a compatibility story of clients pointing to SQL servers. But as it stands right down today, even when we do SQL Server, the next release, it's very likely that that will still be blank right there. And what I'd like to do is kind of talk a few more things about Linux and our architecture, do a demo, and we'll stop and we'll take some questions. So as I said, we adhere to the package management systems of these different distributions, whether it be RPM formats for RHEL and SUSE, and those are 2 different RPM files native to those systems, and then support the ecosystem for package management. And quite frankly, working on Windows for so long, and I think we do have a good installation story for SQL Server on Windows, but package management blows it out of the water. I mean, it's incredibly fun in my mind, and I don't know how many times I've demoed it, to use the package management systems of these environments in Linux to install and deploy SQL Server. It's actually quite amazing to show it off, right? And in that true sense, because package management in these systems have dependencies and version control and automatic update facilities and things of that nature, we have broken up SQL Server into several packages. So you don't just use one big package for everything for SQL. For example, the MS SQL-Server package includes SQL Agent and the core database engine. But if you want to install the tools like SQL Command, you use a different package. If you want full text search or HA capabilities to enable, you use different packages. And then for IS, which is SSIS, which we do support on Linux, you would have a different package as well. And I think you can count on us as we move forward using that paradigm. If we think there's a fairly major big thing we're going to do, it probably might show up in a new package versus, continuing to take the SQL one and making it huge. And you should know that we support everything that you would think of in a package management system, whether it's updating SQL Server through, say, a yum update, or doing something offline, or removing SQL Server. What you're used to doing with those package management systems, we support that functionality as well. Offline installs, that kind of type thing. Now, one thing we had to do different for SQL Server on Linux that we did on SQL on Windows was configuration. If you're a SQL Server user, you're used to configuring SQL Server through many different mechanisms that are supported through the T-SQL language. For example, there's a system store procedure called spconfigure. There's alter server configuration, which is a built-in SQL Server command. You might configure things at the database level with alter database. But there are some things that cannot be configured with the T-SQL language for SQL Server at what we call the instance level. And in Windows, you would use a graphical interface or PowerShell or WMI for something called Server Configuration Manager. And that could be changing the port for SQL Server or log directories or different various aspects of SQL. So on Linux, in a true Linux form, we created a script. So mssql-conf is a bash shell script that ships with the product. It is powered behind the scenes by a series of Python scripts, which is why we do have a dependency installing Python. And so when you want to configure things like I show you down here, like a startup trace flag, for example, you would use this mssql-conf script facility. We do support environment variables, though, so you have the ability to do a complete unattended install. When you set certain environment variables and you just run SQL Server, we actually recognize those and will automatically try to configure things that you would normally use this script for. And you're going to see when I show you a demo on Docker containers, it's exactly how you're going to use Docker. So that's a little bit different, but the functionality being the same to be able to configure things. And this script runs the same no matter what the distribution looks like for SQL Server with RHEL, SUSE, or Ubuntu. Okay, this is my fun slide. My fun slide because I've got a reputation in the SQL community for doing things that are very deep. And so when people see me present up to this point, they're like, what the heck? I thought this was going to be a Bob Ward deep presentation. And I'm sorry to disappoint you. The rest of the presentation after this is not a very deep presentation because, again, I'm trying to introduce you to this whole topic. But I love kind of drilling down a little bit and taking a second for the brilliant architecture that our engineering team built to make SQL and Linux a reality. So when we had this decision to make, there's this really smart guy that I work with named Slava Oaks that leads our engineering team. This is the guy who built SQL OS back in 2005. Probably one of the smartest engineers I've ever met at Microsoft. And when Slava joined the team, he rejoined the team back in SQL to work on this project. He looked at a couple of possible choices. One was to take the SQL Server code base and completely port it to Linux, which would require a couple things, as you can imagine. Recompiling all the code with Linux compilers to run on Linux because of the calling conventions and things of that nature, and to change all the calls that we had to make to Windows APIs to Linux kernel APIs. Now, as it turns out, part of our engine code is abstracted from Windows operating system with a component called SQL OS. So that might have been not too hard to go in there and change those pieces, but it's not just SQL OS in the SQL engine and things like SQL Agent that use Windows APIs. So there would be a lot more changes that have to take place, what we call a native port of just SQL running on Linux. So if you look at the right-hand corner of this slide, you'll see this project called the Drawbridge project. The the research team at Microsoft back in the late 2010 timeframe, 11 timeframe, this is kind of when the container ideas was starting to kind of come to light a little bit. They took on a project where, without containers, they wanted to build a system with Windows. Windows was their target, where they could actually take an application and run it in an environment, what they call a Pico process, and a process where the application would not really actually, quite frankly, understand it's running on Windows and be abstracted from Windows. But more importantly, they would actually take some of the API calls that the application relied on and take some of those, and instead of requiring a context switch into the kernel to implement the API, it would be implemented inside the user mode space. And so they built a piece of software called the PAL, the Platform Abstraction Layer, where this Platform Abstraction Layer would take an app that's running inside this process, and as a API call came down into this PAL layer, it could decide, do I need to go to the kernel for maybe a core service like I/O or thread or memory or something, or could I implement the API myself, like a registry call, inside this user mode space and not have to go to the kernel? And so it was really cool. You can go, I've got a link to this project, you can take a look at it. What the result of this was the app was running a lot faster and lighter in this environment, kind of like a container thing, where only about 40 or 50 API calls had to require a kernel context switch, and then the rest of them were implemented in user mode. So Slava looked at this project, talked to this team. So it turns out they had started building a prototype for Linux, where they could take a Windows process, run it in this drawbridge environment, and it could literally run on a Linux host operating system without compiling the user application on Windows. And what you see in front of you is the result of this architecture. Excuse me a second, let me go back here, of this architecture. Now let's just unpack this a little bit, okay? So on Linux, when SQL Server runs, if you look at the left-hand side over here, there is a Linux process called SQL Server, SQL SERVR. And so this bracket represents everything kind of in that process. The red box represents everything that's running in an environment that really thinks it's running on Windows, doesn't really realize it's running on Linux. And the reason we pull off this magic is because of the fact that we're all in an Intel architecture in this case. All of this stuff is just assembly code to run on an Intel architecture. So provided that we know a way to boot up the SQL process to run and boot up the Windows processes that SQL relies on, that we need to run, and we take the PAL concept from the Drawbridge project and we kind of infuse that with our SQL OS that we've done before, and then we use this live OS concept to intercept those APIs, just like the Drawbridge guys did, to determine, can we implement those, or do we have to go down into the Linux layer to implement them, right? So that's kind of what we've done. So in a way, you can think of this as SQL Server or SQL Agent, which it's weird, I realize, to show this, run in the same Linux process. They, in effect, don't know they're running on Linux. They in a way, really believe they're running on Windows. So all the calls that SQL Server makes, either into SQL OS or into Windows APIs, get translated into this call to something called host extension. Host extension is a piece of code that we did natively compile for Linux, and it's the one that understands the kernel. Now, this is not emulation. This is not virtualization. These are direct assembly calls being done between these two environments, between this red box and this black box. So things are very fast and lightweight. But here's the beauty. Because we've done it this way, the SQL Server gray box, which represents the core engine of SQL, which supports column store and query store and in-memory TP, all of that functionality is unchanged. It's the same code base that runs, quite frankly, between SQL on Windows or SQL on Linux. So it's absolutely identical. And that's really, really a powerful thing we've done here. It allows us not to have to maintain two code bases. And because of the ability how we've done of this lightweight layer of translating when we need to for I/O memory and CPU, it's very fast. And that effectively is the Linux architecture that we've got for SQL Server. So when SQL Server on Linux boots up, what happens is, to this bottom right-hand corner here, is there's a SQL Server process that we affectionately call the watchdog process. It's natively compiled for Linux. It contains this host extension code. It knows how to fork off another SQL process in Linux. That's why you're going to see two of them. And then the main SQL process will kick in to run all of this logic. So when a query gets executed, when an app connects into SQL, it executes in this gray box here. If any API calls need to go to the Linux kernel for, say, I/O, it'll run to this host extension layer into the Linux kernel. It's really a clever way we've done this, and it's the only way we could have pulled this off to come to market so quickly with SQL Server on Linux. But again, performance is very, very good, and we've proven that through our TPC benchmark. So it's a very interesting thing we've done. There's actually documentation and a blog post done by the SQL team, engineering team out there more about this architecture. It's pretty interesting how we've done it, and one of the most innovative projects I've seen us do at Microsoft. Let me stop for a second and do a demo, and then I want to take a second to come back and see what kind of questions you have before we move on. So, okay, so let me come over here. Everybody has their preferred secured shell environment. This is a Windows laptop that I have. I prefer this program called MOBA Xterm. I love this thing. A lot of the reasons I like it is because it does copy and paste and drag and drop and those kind of type things that I need when I'm running, say, on a Windows environment. So what I have here is I have a secured shell into a Linux virtual machine running Red Hat Enterprise Linux on Azure. And in this environment, I went ahead and did the installation for SQL Server just for the sake of time that we have today in our session. I'm not going to show you the installation itself. You can do that. It's very, very simple to do. In fact, if you go to those self-paced Linux labs, we walk you through that actual process. And then our documentation, if Ubuntu is your favorite Linux distribution, we have apt-get examples, Zipper for SUSE as well. I will show you, though, that I do have a history of yum here. I'll just run sudo yum history of installs I've done, and you can see, I'll just put in my password. You can see here, this shows an installation that I've done of SQL Server, and this was the command. Yum install -ym SQL Server, that's our package. Now before this, I had to pull down with curl what's called a yum repo type file, which inside it tells you on the internet where are our packages. But you see here, this is what was installed. And what's interesting here, when you do a yum install, which can be done in a matter with a decent internet connection of, say, 60 seconds, we have you run this command to finish the installation. So there's that MS SQL conf script where you use the setup option. That is where we prompt you for what edition of SQL Server. And by the way, all the editions of SQL Server are the same for Windows and Linux. And the licensing is the same for SQL on Windows and Linux. So you buy a license for SQL, you can run them on either Windows or Linux. It doesn't really matter. So you pick the edition, you accept the EULA, you put in your system administrator password, and then we finish this script. And I would say nowadays, in little over a minute, I can be done installing SQL Server. And again, the thinking is that get the basic install done first and do all your configuration steps afterwards, which is kind of the opposite of Windows, where we ask you everything up front and do everything all at one time. Or install a feature like full text search, you do that in Windows at install time. For here, you do a separate package installation to get that done. So that's the process I did to install, but let's say you want to explore a little bit. Now what I've done also here, I've also installed a separate tools package for SQL Server. Let me just do a basic connectivity that you're probably used to with SQL command just to connect. I'll put in my SA password here. And I'll just do the basic add version. Now I'm going to talk about a little bit later that we do support Active Directory authentication, so you can do integrated security type connections, not just SQL authentication. But this just shows the basics that I'm running SQL 17 with our cumulative update 10, running on Red Hat Enterprise Linux. And then I would interact with SQL Server at this point just like any other SQL Server on Windows system. And SQL Command is one of the examples of the tools that we ship. We natively have compiled SQL Command to run on Windows, Linux, and Mac. We'll talk about tools a little bit, more tools here in a second, but you're going to see that a little bit of our tools philosophy going forward is any new tool we build, we try to make that tool both cross-platform and open source as well. SQL Command is not open source. I'll show you in a second an example called MS SQL CLI, which is. But if you're used to looking at things on Windows for SQL from a status perspective, you would use like this systemctl command. And I'll use sudo here because I want to see information about the error log. So I'm going to look at the SQL Server service or systemd unit service. And I'm going to see the SQL's running. And actually, when you use sudo, we'll dump out the last few lines of the error log here. We'll see that in a second. Notice here really quickly here, the processes, though, that make this up. There are two SQL Server processes, and that falls in line with the architecture I told you about. The first process being that watchdog process, and the second being the actual SQL process that's running the engine. But you may want to see where the error log is and all the other files. So you would go to a directory called var opt ms SQL. And if you went there, you can see, maybe you're familiar with this, the data directory, with the default directory where the system databases are. you have the ability to change where that directory is, or the log directory. You look here, maybe this looks familiar. Error logs, default trace files, default system health session, and I can even do something like just cat out the error log to see what it looks like. That's very familiar to what anybody probably is used to seeing in a SQL type world. So that's just basic functionality of just traversing where is SQL installed and what do we do and where it is on the system. We've introduced a new command line tool, kind of the next evolution of SQL command, called MS SQL CLI. If you've not seen this before, it is both open source and cross-platform because it's based on Python. It's kind of some interesting functionality if you go connect with this. Let me put in my password here. So number one out of the gate, you're going to find that what's different is there's IntelliSense built in. So if you start typing here, you're going to see IntelliSense come up, prompt you for both syntax and objects in the system. And another thing that I love what they've done here is one of the things that drives me nuts using SQL command when I'm forced to use it is the wrapping of data with long character string columns where I can't line up what's the value to the column. So the default for MS SQL CLI is a vertical format. So if I just want to see all my objects in the master database and run this, you'll notice here that everything appears in a record vertical format so that, yes, you have to scroll to see all your records, but you see each column in those systems. You can change what that looks like, but that's the default. So that's MS SQL CLI. Again, that's going to look the same here, whether you're on your MacBook, on Windows, or on Linux. Now, I told you compatibility is a big story. So I also have over here a Windows machine, a Windows virtual machine in Azure that knows how to connect to the Linux virtual machine. So they're both in the same resource group in Azure. And notice here on this Windows server that the default is a SQL Server on Windows that I've got. But look here, I've actually got a connection to SQL Server on Linux. This is the actual server I just showed you. So if you're a Management Studio person used to using that tool and you're like, hey, does it work with SQL on Linux? Is it different? Well, it pretty much is the same. The only differences you're going to find are some functionality that are specific to Windows, or like a feature like REPL or Polybase that we don't have yet supported on Linux. But for example, you don't restart the service with Management Studio because that's dependent on Windows APIs. But your interaction with SQL Server, like just kicking off a query, is identical. You know, just like the select add version I showed you there in SQL command. Whoops. You would just run the same thing here, and you see here you're running against the SQL Server on Red Hat. The same thing. So from a compatibility story, things like Management Studio work unchanged. Just point it to your SQL on Linux, get the right connection string, and you're ready to go. Another new tool, though, that you may or may not have seen is something called SQL Operations Studio, and I have an example of it right here. This is another example of a cross-plat open source tool based on Visual Studio Code platform, and it's pretty cool. So again, you're a MacBook user, and you want to run a native tool for SQL Server now on a Mac, use SQL Command, or now you use SQL Operations Studio. I've got the same functionality that I might see in Management Studio for queries. For example, here's a query with a show plan to see what the actual query plan looks like for running execution. Or what the SQL Operations Studio team has done is built in a system where you as a developer or community contributor can add something called an extension. And so when you manage a server, you have a basic Explorer interface here, Object Explorer interface, just like you have Management Studio. But also, when you manage a server, you get like this dashboard to show you some basics about your server. And then there's a series of extensions that we've built, like, for example, server reports to show you wait counts. That is very popular from Paul Randall, database usage, or even things like community contributions like SP Who is Active from Adam Mechanic. If you click on extensions here, you can see we're starting to build up quite a marketplace of what different extensions the community is starting to contribute towards this effort. So that is kind of the future for us. Management Studio, still making investments in that. We're still a big believer in that, but that will always be a Windows tool. If you're looking to run things on Linux or Mac, this is going to be your preferred tool. And again, this extension concept I think is very powerful for how the community is going to start adding in functionality. There's even things for like controlling SQL agent jobs and some of that kind of type nature. So that's your tool set. SQL command or native tools like BCP, natively compiled for whatever environment you want. You can use Management Studio that you're used to using on Windows, perfectly compatible, or you can use Operations Studio now, cross-platform and open source. That's just a brief tour to using SQL on Linux. And by the way, the reason why it doesn't seem like, hey, Bob, where's all the magic, of me connecting to SQL on Linux? Remember, the core database engine's the same. So, you take your favorite tool or app and point it to SQL on Linux and watch how compatible it truly is. Let's take a second, because we're about halfway through, a little over halfway through. Let's take a second and see what questions you might have. Andrew, anybody ask any questions so far, or posting any questions?
Yes, we've got one from David here saying, hi, is there any improvement about tempdb configuration during installation? So automatic number of files, file location, things like that.
Great question. Thank you, David. So as you know, in Windows, we offer during the setup process the ability during installation for you to pick the number of tempdb files and sizes, and then if you don't pick it, setup just automatically configures one based on number of cores. We don't have that functionality yet for Linux, but David, that's absolutely one thing we've asked the team to add in and provide that functionality through like MS SQL Comp. So we're definitely looking at that.
And we've just got another one come through here, just saying, does SQL Ops Studio have all the functionality as SQL Server Management Studio?
It's a fair question. The answer to that question is about the functionality between the two is the answer is no. A lot of the basic functionality they're used to use in Management Studio does exist in Operations Studio. I think I would look at it this way. If you're a database administrator and you use Windows, I think you're going to prefer to use Management Studio still as your preferred platform. If you're a lot used to doing more work with data, developing T-SQL scripts, running T-SQL things of that nature, or you're like a Mac user and you'd like a native tool, then Operations Studio is going to be your preferred platform. We're still trying to figure out, how do we marry these two worlds? Do we go for putting all the functionality of SSMS into Ops Studio at some point? So we're still trying to figure that out. You're going to find a lot of things, though, that you're used to using in Management Studio do exist. Again, I showed you query plan capabilities. The extension concept in Operations Studio, where the community, it's open source, right? Where the community comes in and starts contributing these extension concepts is a little bit interesting, and may start providing some new functionality in Ops Studios that Management Studio is not capable of. But there are some things in Management Studio, right-clicking on things in Object Explorer and performing certain tasks or wizards that are provided in there, that will continue to be probably a feature that Management Studio will have that Ops Studio doesn't have. But we're still trying to figure out down that path. I think you're going to see a lot more come out from the tools team here in the next couple of months about their strategy with these. So stay tuned kind of from them about how they feel about these and when you would use one versus the other.
Okay, and we've just had a whole bunch more questions come in as you're answering that.
Yeah, go ahead.
The next
one
was, how does performance compare between Linux and Windows?
Wow, I should pay somebody that thing. Let's talk about that in the next slide. I'm going to talk about performance next.
Okay. What is the status of MS SQL Server Agent? Seems behind several versions. From Thomas.
The question is about SQL Server Agent on Linux?
Yeah.
So SQL Server Agent on Linux does work on SQL Server on Linux. The difference is that the only types of jobs you can run are T-SQL jobs today. SQL Server Agent on Windows supports things like command exec jobs and some other types of jobs, SSIS type work and so forth. Today, SQL Server Agent only supports T-SQL jobs, so there's no way to run like a shell job or something of that nature. There's some other things you're going to see coming along that are going to maybe supplant some needs for that down the road, but right now that's the biggest difference. Other than that, it's the same SQL Server Agent code that runs on a Linux as it does on Windows.
Next one.
I think I've answered that.
Yep. The next one is, does formal documentation exist on how to set up HA and DR using Pacemaker?
So great. We're going to talk about HA and Pacemaker, and yes, we have a set of documentation that goes through step by step about how you would set up Pacemaker, both for a failover cluster instance and for an availability group.
Okay. Last couple, is the huge pages configuration supported by SQL Server on Linux?
It's a great question. So we have and I'll talk a little bit in the next slide about this. We have what we call a performance best practice page for SQL on Linux. And what we've kind of landed on is to adopt transparent huge pages to be set on your system. We don't explicitly write APIs for huge pages. We don't feel like we need to do that, at least today. So we just rely on transparent huge pages, and as our code executes and runs, it'll take advantage of huge page concept as the Linux kernel will use transparent huge pages. So that's what we kind of rely on today.
Okay. Last couple. The first one, the one I want to mention here is any thoughts about running SSIS on Linux? I think you mentioned that earlier.
SSIS, and I'm sorry I didn't call that out specifically, but we do support SSIS. So the way it works is you design your SSIS packages on Windows. All the designing tools work there, right? What we have is DT exec, like the runtime for SSIS. That works using a SQL PAL. It's a separate process, but using that same SQL PAL concept. So you can basically design your packages and then take those packages and run them natively on the Linux system using DT exec. So SSIS is supported on Linux. There are some restrictions. You should look at the documentation for kind of what those look like, but the native basic functionality of SSIS does exist.
And the final one is, I think this is, will those extensions, the SQL Ops Studio extensions, be added to SSMS?
So the question, it's a great question. The extension format and the way you write an extension Ops Studios is completely built into Ops Studio framework. It's built on the Visual Studio Code concept. So those aren't compatible. We don't have a way to run an extension inside Management Studio because that's a completely different infrastructure using the Visual Studio shell. I think what you should do is kind of stay tuned over the next month or so to hear what this tools team strategy is for how these two worlds kind of work together. But I'm not aware today, at least, of how you take an extension and just port it to run in Management Studio, because again, it's two different infrastructures that they've two different platforms that they've built. The Visual Studio Code platform, which they've based Ops Studio on, does give them that capability of extensions, which Visual Studio Code also supports, plus the ability to run cross-platform. And then again, it's completely open source. So people can go in and take a look at the complete source code and everything we've done with it, and even file bugs and fix bugs. We even allow that, so you can go ahead and do that yourself. You know, contribute to say, hey, I think I've got a bug fix, and then you submit it, and then we decide whether we take it or not. So.
Okay, brilliant, and that's it for now.
All right, let's kind of move on here a little bit. We want to make sure we get to containers. We've got about 18 minutes left. So those are great questions, and I'm glad we stopped to answer all of those. So just briefly about performance, somebody said, is the performance the same between Windows and Linux? So the answer to that question is that the performance is similar. And why do I use that term? It's because it just depends on your workload. There's no way we can make a claim to say you can take a workload and it runs 100% the same on Windows and Linux. They are two different operating systems, obviously. What we found from things like benchmarks is they run about the same. We did make a conscious decision that TPCH as an analytic query type benchmark, we wanted to prove our performance points. So we took TPCH out of the gate with our partners, and we told our partners, hey, you guys interested in doing something on Linux? And they were like, heck yeah. And so the #1 TPCH benchmark for 1 terabyte today, for example, is on Linux. So we're pretty serious about performance. My experience, practical experience right now is I have not found a workload or an application so far that runs drastically different between Windows and Linux. They're pretty much just about the same. I would say to you, anyone on the phone here listening, do not make your decision to run SQL Server on Windows or Linux on a performance consideration, unless you've got a hardware package with your partner that requires Windows or Linux, right? From the core engine SQL Server performance point of view, we feel it's very equivalent. And in fact, that's why things like column store indexes, Emerald TP, they run unchanged. It's the same core database engine. And we've done some fun stuff. We just want to prove how fast we can be. Travis Knight at Ignite, I did this. Travis and I did this at Red Hat Summit. We've got a YouTube video showing this where you can scan 180 billion rows in like 20 seconds. I was at the HP Discover event. You may have seen this on Twitter, where I'm standing next to this demo machine and I show the scalability of SQL on Linux running. So we can run that same query on SQL on Windows as well and show the same capability. Don't forget about things like adaptive query processing and automatic tuning. Really amazing, cool automation features in the SQL engine that allow you to take advantage of what I call automatic intelligent processing for performance for SQL. That runs the same on SQL on Linux on Windows. And I've got some pretty cool YouTube demos to show you how that works in a Linux environment. And then as before, we do have a series of Linux best practice guidelines we have for kernel tuning for SQL Server. We've got a documentation page. It's only like 1 page to go through. It's very few changes to make, where we've gone through and said, oh, here's what we believe are the kernel tuning parameters you need to make to run a database engine like SQL best for your environment. So we've got that. We've got people on our team that have Linux backgrounds that help us put that together. Security is a great story for SQL Server, in my opinion. And for SQL Server on Linux, the great story is that the following, is that from a feature set point of view, it's just about the same as SQL on Windows. All the stuff that you see runs on SQL on Windows, like always encrypted, Row-level security, dynamic data masking, Active Directory authentication, it works on SQL on Linux as well. The difference is configuration. So for Active Directory, we have to have Kerberos capabilities. And so we're going to use like Realm or something to go in and configure SQL Server to support that. And we're starting to explore how could we do that with other LDAP providers, by the way. Whereas in Windows, it's a different system, right? You're going to see the same thing for HA as well. So the functionality being the same, but in some cases, the configuration being slightly different. Doing like connection encryption, for example, it's going to require some slightly different configuration. We've got it all documented on Linux than you would do on Windows. But again, we wanted the core functionality of encryption to be the same between the systems. So it's a great story from a feature point of view. All that stuff you know and love on SQL and Windows works on SQL and Linux, slightly different configuration in some cases. Don't forget too, for those in the phone that care about GDPR, we've got new functionality for SQL Server for doing vulnerability assessments and data classification. I think you're going to like what you see there. We've got some great demos on how to do that, and that's going to work on SQL on Linux as well. And then finally, there's HADR, where people have talked about, I have a need for that for SQL Server, because in some cases, I have customers literally that their HADR story is just backup restore. That's all they care about. Their RTO and RPO needs don't require anything different. But a lot of customers have to have something else, right? So here's kind of what works with SQL on Linux. Number one, a shared storage solution like failover cluster instance is supported for SQL Server on Linux. But what we're going to rely on are open source platforms like Pacemaker and CoroSync to make that happen. And we've written a resource agent that works with Pacemaker and CoroSync that you would install separately to make that work. So the same functionality, though, of SP server diagnostics and failover cluster detection and some of those kind of things, that works the same. But we have to write a separate resource agent on Linux to kind of combine that with the Pacemaker and CoroSync environment. And in fact, we've open sourced that code so you can take a look at actually what we're doing. So that's failover cluster instance. Now, a lot of people out there like the ability to do something different even on the Windows environment, and they don't want a shared storage solution. They want a shared nothing solution. And they like the ability on the secondary or replica instance to use SQL Server. They don't want this just sitting there passively not being able to use it. So availability group, as you know, has become very popular for our customers. For SQL Server on Linux, we support a new cluster type called external for availability groups. When you specify external, that means you're going to do a SQL Server always on availability group for Linux. And so we've got this set up as well with Pacemaker to support failover capabilities. There's a little bit of a difference here. Because of the nature of the way Pacemaker works, you're going to need a third replica to make this system work correctly and to support things like Stoneth and the way they do quorum. So unlike Windows, you actually have to have 3 replicas involved to do a highly available availability group. And here's the good story, though. That third replica instance, what we call a configuration-only replica, can be SQL Express. So you can take a free version of SQL and make it that third replica. But you get full AG capabilities, failover, read capabilities on the secondary, sync, async, however you want to do it. So the third type of availability group is really interesting for SQL 17 because it's the same on SQL on Windows and Linux, and that's called a read scale availability group, or cluster type equals none. We discovered, and we've known this for a while, that our availability group software in the core database engine supports transmission of log blocks to replicas without the need of clustering software. The clustering software is only needed for failover capabilities. So we've now exposed that through this cluster type equals none functionality, where if you don't need auto failover capabilities, you can set up what's called a read scale availability group with primaries and replicas, and you don't need Pacemaker at all. Or in Windows, you don't need Windows failover cluster. You just need SQL Server to make it happen. So that's a pretty nice functionality. And here's the cool story. That's cross-platform. Because the core database engine is the same on both systems, you can set up a primary Windows and a secondary Linux, or even vice versa, between the two systems. That's called read scale availability group, pretty cool functionality. And again, that's independent of SQL and Linux or independent of Pacemaker, but I wanted to call that out here because a lot of people miss that we have that functionality. Because of the fact that we're using Pacemaker, and because of the fact that we've made this resource agent open source, it's allowed our partners to build solutions that work with SQL Server on Linux for HA capabilities. So if you go look at this website we've got listed here, We've got some partners that have built their own solution that support availability groups or failover clustering with SQL Server, and you can use those as well. HPE, for example, has got a solution they've got out there. Go take a look at the partner ones. That may be something you may look at versus just setting this up yourself. And as asked earlier in the discussion, there is a full documentation page that we've iterated and improved on. I myself have been involved in that because I've set this up myself to help make it better. But full set of documentation steps on all three of these environments to how to make one work, whether it be failover cluster instance, availability groups, highly available groups, or a read scale availability group. So take a look at that documentation. It's got all the pacemaker commands, everything you need to go set up one of these environments. Okay, just briefly about our tools. I kind of hammered this a little bit already to you guys that we're a big believer in still iterating on Management Studio. Our data tools is still available out there. That works with SQL on Linux. Third-party tools, if you go look at third-party monitoring systems like Redgate or SentryOne or SolarWinds or Ardera, they work with SQL on Linux. Drivers and frameworks, which is a great solution for us, that works on SQL on Linux as well. And then you look at this down here, this kind of philosophy that what we're going to build in the future of new tools, we're going to try to make sure as best we can that any strategy for that is going to be both cross-platform and open source. And you can see that from the examples I have here, SQL Operations Studio, and I showed you MS SQL CLI. So I think the tool story is a good story. I will just tell you internally, as a person that works at Microsoft for 25 years, I have never seen more people or more passion or more strategic work by our organization to invest in tools. I mean, we've hired some really top people to go run that part of our organization. I meet with them all the time and talk to them about their strategy. And I've seen it. I've seen us invest and de-invest in tools across the spectrum over 25 years. I think our tool story has always been a good one. But now what I see is a actual consistent strategic way of looking at this from a really talented set of people. So I think you're going to count on that from going forward from that group. Hey, let's kind of finish off here. We have 8 minutes left here to show you a little bit about Docker. Got a quick demo I want to show you guys. And if you've not taken a look at containers, I have to say that probably nothing's hotter that I've seen in the industry when it comes to things like SQL Server or applications to consider than containers. And for me, this is kind of my viewpoint about why would you want to do this. Portability, number one. So you take a Docker image, and anywhere Docker runs, you get to run it. I don't care what environment it is. If Docker is supported, it can run your image, and SQL Server is one of those. It's lightweight because of the fact that it doesn't have the entire operating system in the environment. And you see the diagram to the right over here, that containers rely on the fact that Docker is an environment on top of the host OS itself that supports running multiple process isolation containers. Without using the complete virtualization environment. That's why they're lighter and they're going to be potentially a lot faster and easier for you to manage and deploy than virtual machines. And then from a SQL Server perspective, it's consistent. You get a SQL Server image as a base for what you're doing, and now you have consistency in people testing and using that. And then think about this little diagram right here. Let's say in my Docker environment, I have 2 SQL Server containers running side by side, in which they're isolated, but they're 2 SQL servers. And by the way, we don't support named instance on SQL on Linux, so this is how you're going to run multiple SQL servers, is using containers. But let's say I have a scenario where this container is running SQL Server, say, cumulative update 9 or cumulative update 10 or whatever it is, and I'd like to update my SQL Server to the latest cumulative update. Well, you could patch the existing SQL Server if you wanted to. You could do that. Or what you do instead is just switch containers. So this is an example where a container points to a database on an actual persisted volume, and then all I need to do is stop this container, start up this one pointing to the same volume, and boom, I'm running the next cumulative update. And I might have taken this container here, and I might have tested it with SQL Server already to make sure it has everything I want to do compatible with my application database. But the switching part is going to be much faster and more potentially less error prone and test worthy than just patching. And so the other cool thing is, what if I want to switch back? I could simply stop this one and go back to this one in a very easy manner. So going back and forth, that idea of faster deployment and less downtime is certainly going to be possible in a container environment. The other thing that I think is very exciting about containers is the environment called Kubernetes. And if you're learning to speak Linux, and you're on the phone right now learning to speak this Linux language, go learn containers and Docker and Kubernetes. It's also called K8S because if you don't know what that is, it's you take the K and the S and there's 8 letters in between, so the shortcut is K8, the number S. If you ever see that, that's the same thing what Kubernetes means. And what I love about it is it's one thing to take a couple of containers and just run them, but what if you need high availability? What if you need to orchestrate a lot of containers in a production environment? So Kubernetes supports this. It's an open source project that's also now built on commercial distributions where you can run it in the cloud and on premise. You think of Azure Container Service, you think of OpenShift, a lot of different people running Kubernetes now in production environments, and SQL can be part of that. So consider this scenario. Kubernetes has this idea called a persistent claim or persistent volume storage, where you would claim on storage. So you put your SQL databases on the storage, you configure Kubernetes so that SQL Server runs in what's called a pod on a node. Now what you're going to do, and Kubernetes has this built in, and we have instructions on Azure how to do this, you can set up what's called a load balancer service with a known IP address. So that IP address stays the same. And so what you do is you point your app or your tool for SQL to the load balancer service, which knows how to connect to SQL Server, whose IP could change if it's running on different pods or different nodes. Let's just say that the pod has a problem. Now, if the pod has a problem, Kubernetes by default, if you set it up properly for HA, will start up a new pod, could be on the same node. The load balancer automatically redirects to that new pod, that new SQL container, and then it points to this persistent volume because that's where SQL was stored already. Your app just had a reconnection, like a retry of a connection. This is very much like a failover cluster instance type scenario. Same thing as if a node goes down, Kubernetes is smart enough to go on a different node, start up a new pod with the same SQL container pointing to the same storage, and now you're just in the same scenario. And it's also even, Kubernetes is even smart enough as well that if SQL one goes down inside the pod, it knows how to restart the SQL container in the same pod. So it's kind of like built-in HA without you installing Pacemaker or any of this software. I've tried it, and you yourself can go online and see our steps with Azure Container Service. It's actually way cool. It's a pretty incredible technology, and you're going to see us and Microsoft and SQL Engineering really rely on the Kubernetes technology in the future for a way to scale out and build a SQL Server in new different ways. And in fact, what you're going to see from us, I think we've already demoed this in YouTube videos, is take the availability group concept and try to make it work within the same Kubernetes environment. So let's just show you a quick little demo if you've not seen containers before. I have a few minutes here. So in my Linux environment, I've got Docker running, and so I can type in Docker PS to see, sorry, sudo Docker P. I need to run sudo here. What kind of Docker processes are out there running already? Oh, sorry, I need to rechange my password here. And I don't have anything running. Now, what I've got on here, though, what I will show you is I've done what's called a pull of Docker images. So I've got two images. I've got a Docker image for SQL Server CU9 or Cumulative Update 9, and then the latest CU. So I could do something like this. I've got these shell scripts out here, and they're in our lab so you can see them. So I could do a Docker run CU9, which is going to actually run, I can cat this out here, U9sh. This is going to do a Docker run. Here's where I'm putting these environment variables that I told you about for EULA and SA password. I'm going to map the port 1433 on the host machine to 1401 so I don't have conflicts. I'm going to say map the local directory in the container where SQL's databases are to the SQL volume, which will make it on the host machine as a persisted volume. I'm going to call it SQL1 so I can just manipulate it, and I'm going to use the CU9 image. So now if I run Docker PS, it's up and running, and I can actually now interact with it. One thing I could do is I can copy a database inside there. So I can do a this Docker copy script, which will copy the worldwide importer sample on my host machine inside the container. And then I can do this. This is a command where I'm going to run a restore of that database inside the container. So I'm going to tell the container, hey, go run SQL command inside this container, take that database I copied in there, and restore it. Now, with a container, while the container's running, or even if you start and stop it, the database is now available. But unless you use like a volume or a persisted volume with Docker, if you remove the container, it'll remove all the data that goes with the container. But because I use this SQL volume here, this named volume, which is stored on the host, even if I remove the container, that database and that data is still persisted and available. But what I'm going to show you here, and I realize we're just about at the end of our session here. This will just take a second to run here. I'm actually running and restoring the database, And then what I'm going to do is I'm going to query it, so I can show you a query runs against it. Then I'll stop this container. I'll start a new container based on the latest version of SQL Server and just point right to the same database. So I'm just running a query against this. Now here's the cool thing. I'm running SQL command though on the Linux machine. So you do this, look at my query here. This is just running SQL command. Now notice I'm using localhost, that 1401 port I told you about, against this database. Now what I'm going to do is I'm going to stop. Let's do a stop SQL 1. I'm going to stop that container. Okay. Now I'm going to start up this time. I'll show you what this looks like. A Docker. This is going to be the same Docker command, except this time I'm going to use a different image, which is the latest SQL image, which is CU10. And I'm going to call it SQL 2. So let me run this thing. Now it's going to kick off. Go back here. And it's now running. Now the other one's not running. This one's running. I can't run two at the same time against the same SQL volume because I can't open the same system databases at the same time, two SQL instances, right? Two versions of SQL running. But the difference here is now I just kind of did an upgrade to CU10 with SQL Server without patching SQL. I'm just running a separate container that's pointing to the same set of databases now without actually doing this. Now what's interesting is within the CUs, we've got some upgrade scripts that have to do some changes to some system tables, but it's backward compatible. So I can swap back and forth between these CUs. In fact, if I think I've run this query here, oops, it may come back and tell me it's still doing a, let's see, let's just run this. It may be doing an upgrade step still. Yeah, see, it's saying it's in a script upgrade mode. That's because inside the container, it's actually doing some upgrade of some scripts. And I can actually interact with this thing. I can say, let's do it this way. I can do something like this. I can say sudo, Docker restore. That's the one I'm looking for. That gives me, this is an example of how to interact with the container through a shell. So I can say docker exec -it SQL 2 in this case, bash. Now I'm running a bash shell in the container, so I can change to the var opt msql log directory. This is in the container itself, and look at the error log. I think it's actually finished now. So I can go back here and run my same Docker query, and it's the same query, it's the same data. So it's an example of me upgrading SQL Server without patching SQL Server in a new and exciting way. And I think you're going to see that that's something that we are going to consider doing and allowing you to do across major SQL versions as we explore the next version of SQL Server. So new types of deployment, new way of running SQL Server. Look for more information about Docker. I've already announced I've got some really interesting Docker sessions coming up at major events like Ignite and Pass, where I'm going to dive into the internals of how Docker works. So I'm going to tease you there about that. But that's kind of like where we're headed towards, and that's some examples, basics of using a SQL on Docker. I know we're running out of time here, so, and in fact, I apologize, I'm 3 minutes over. So let me just briefly tell you what's coming next. These are planned things we're looking at for SQL Server on Linux for the next release of SQL. Stay tuned. I think you're going to hear a lot about that coming soon about it. And really the big thing for us is to do a couple things. One is to shore up any feature gaps that we've had between the two, SQL on Windows or Linux, and then start exploring more new ways to use Kubernetes and Docker, and then take advantage of things like new hardware innovations and make sure we shore up any Active Directory enhancements we need to do. This is a list of all the resources you may want to take a look at. Pay attention to those self-paced labs. Also take a look at the SQL channel. We have a new YouTube channel for SQL Server. Most of our demos we've done just recently are all Linux and containers. So a lot of stuff I just showed you, you can watch yourself in a little bite-sized, few minute little demo. So Andrew, man, sorry I went over a little bit, but that was a lot, I think, wasn't it, for your group?
That was absolutely fantastic. Thank you very much, Bob.
I'm going to stop sharing my screen to let you take back over. And I know we're about 4 minutes over now, but maybe there's a few last-minute questions that folks have hung on that want to ask.
Yep, I'll just grab. Oh,
And Andrew, anybody else there that would like to ask a few questions before we leave?
Yes, sorry, I was just grabbing my screen.
Sure.
So the first question here we have is from David. He's just asking, in the case of a third node configuration only replica, do we need to set up the underlying cluster with 3 nodes?
Yeah, so what you do is you end up joining the configuration replica to the cluster. When we do the documentation, you see the steps, it'll show you how to do that. But using pacemaker commands, you'll actually join all 3 replicas to the cluster. But the configuration replica is joined a special way to denote that it's configuration only, because it's not used in any database information. It's just got metadata about the cluster. And again, if you're concerned about licensing, you can use a free version of SQL to do that.
Okay. Next question is again from David. Just asking, this SQL container is running under root privilege. Is there any plans to change that in the future?
We do. It's still running under root today. We've got that request, a lot of GitHub requests on our GitHub site about Docker, and we absolutely do want to change that. So we got plans to make that change. So a lot of people have asked for that, and we're working on it for sure.
Brilliant. And the next bunch of questions are asking for the resource side, but I've taken control here. So is there a link that I can just post on Twitter to for all the links that you posted?
Well, I think the thing for you to do is to post AKAMS BobWordMS, which is where this deck is. So if you go to that deck, it contains all those resources. But you know, for example, if you just go to your search engine and type in SQL Linux Labs GitHub, you'll find our labs, right? The demo for the labs. If you do SQL Server YouTube channel, you're going to find our YouTube channel with all those demos. So some of the things I talked about and some of those resources are easy just to search and find. But if you go to aka.ms/BobWordMS and go to the SQL Linux directory, you will find this actual deck, and it contains a link to everything I talked about.
Fantastic. Thank you very much, Bob. That was absolutely brilliant. Just a quick note on our upcoming webinars. As I said at the start of the session, we do the first Thursday of each month, and next month we have Alex Long talking about securing Linux on October the 4th, and then in November we have Max Trinidad talking about PowerShell on Linux. So thank you so much for joining us, and thank you again to Bob. We'll see you again next time.
Take care. Thank you very much, everyone. Thank you.